forgotten everything. We might have. 2 to the x. Let's think about what that parent function looks like. So for x and y, I'm going to plug in a few values for x, and I'm just going to graph the parent function first. So a good way to do that is just plugging in values for x. Does anyone remember what a negative exponent does? So if I plug in 2 to the negative second power, what does a negative exponent do? I'm not doing this function yet. I'm just doing this function. What's 2 squared? 4. And then what does the negative exponent do? It makes it the reciprocal of the answer. So at negative 2, I'm at positive 1/4. So if I plug in negative 1 instead, now I'm at positive 1/2. So it just takes the reciprocal. It does not make it negative. What happens when I plug in a 0 into any exponent? 1. So 2 to the 0 power is 1. And now I'm just going to plug in 2 to the first and 2 squared. You should know those values, 2 and 4, right? So any exponential function, I pretty much just use these 3 points right here, because I know that at negative 1, it's just the reciprocal, 0, 1, and then at 1, it's just whatever the base is, 2 to the first, 3 to the first, 5 to the first. Those are your key points. So what I'm going to do is I'm going to graph those key points over here. So I have the parent function 0, 1, 1, 2, 2, 4, 1/2, and 1/4. I'm not going to connect it yet because that's my parent function. Now I need to do this transformation to this parent function. You're going to have this same parent function on all 4 of these graphs. You can do the same set of dots. Then you're going to do just this single transformation. What does a plus 3 do to the x? What transformation is that? Someone please remember. Think of this as parentheses right here. What happens when there's a plus 3 inside the parentheses? Left 3. Who said that? Yes. I think that deserves a mint. Waking up your brain on this Monday after vacation. All right, so if I have to go left 3, all I'm going to do is shift each of these points left 3 dots. So 1, 2, 3, put a dot. 1, 2, 3, 1, 2, 3, and then I know that's 1/2 and 1/4. So I got my parent function from that table of values, and then I shifted them all left 3. And then what's my asymptote? Because my asymptote hasn't shifted. So what's your asymptote always? Oh, really?
Yeah, really.
Don't know what an asymptote is? Who knows what an asymptote is? What is this graph getting closer to? It's approaching it, approaching it, approaching it, but it doesn't go beyond it. 0. So the asymptote is at y equals 0. Maybe it would help if I did it in a different color here. So at y equals 0, you've got this dotted asymptote. You write it y equals 0. So your graph gets closer and closer and closer. That's going to affect your range of your function. All right, let's see if we can do this next one a little bit easier since we've already generated the parent function. So go ahead and redot the parent function on this next axis. That's going to help you practice the parent function. So my intercept is at 1, 1, 2, 2 squared is 4, 1/2 and 1/4. And then what is this transformation? What does a plus 3 do? Up 3. Who said that? Jake said it or Corbin said it? Who said it? Jake? Was it Corbin? I think it was Corbin. He's going to get a mint. You already had a mint. Who said it? Corbin's not owning it, though. So. All right, so I'm going to take each of those points and shift up. 1, 2, 3. 1, 2, 3. 1, 2, 3. See, this is how I do it, too. So don't do it any differently than what I'm showing you. There is no shortcut. You need to know the parent function. If you need to use a table, that's fine. You need to know the transformation rules, left, right, up, down. They're the same as we studied in quadratics. And then if I shift it up 3, what's that going to do to my dotted asymptote? It's also going to shift it up 3. So your asymptote will now be at 3. So your dots should not go below y equals 3. If they go below it, you did something wrong. The intercept should now be at 4, because that's 1 above the asymptote. Good morning, sir. All right, I'd like you to take a look at 3 and 4. Take a minute first and just dot in the 2 parent functions on both axes, and then we will do the transformation. Pause my video. All right, and number 4, give me the 2 transformations that are happening. What does this one do? Right. Oh. Just a negative in front of the x. Over the y-axis. What does this -4 do? Down 4 and flip over this way. So it doesn't matter which one you do first. I would do it in 2 separate steps. So if I was going to flip it over, I might put little X's to show like this is not my final destination, but this is my flip over. Right? So these X's right here, that's like step 1. I flipped it over the y-axis. So now I'm going to flip those X's down 4. So 1, 2, 3, 4 would put me right here. Make that one darker. Let's see. 1, 2, 3, 4. And then 1, 2, 3, 4. And then this must be here and here. Might help if you put in your asymptote first. So your asymptote should be at -4 because it moved down 4. So you got to kind of follow the dots. The parent function flipped and became the X's, and then these X's shifted down 4 to these solid darker dots.
So is that at -3, 1?
So this is at 0, comma, -3. Because the asymptote is here. The point was here. So the y-intercept never changed. This point right here, or this point? Which one are you talking about? This one? This should be at, yes?
On the x-axis.
This one?
Yeah.
Yes, that is at -2, comma, 0. Because this was up at 4 and we shifted down 4. So from here to here, I shifted down 4 and I landed on the x-axis. So this is at -2, 0. This is at -1, comma, -2 right there. And then this is at -3 on the y-axis. And then the asymptote is at -4. It shifted down 4. That was a tough one because it was 2 transformations in 1. But I think you could do it. All right, let me take a peek on the next page. Okay, perfect. This is a good warm-up into the next page I think you could do on your own. So, my asymptote lines are a little bit dark here. You have 8. We haven't done this one yet. We never did this page, right? Okay, so you have 8 graphs of 2 to the x and 8 equations. So these are all single transformations, and you're going to find the matching graph down below. The very first one, let's find together. Where is the parent function? So the parent function, I'm just going to circle up here, 2 to the x. Which of these is the parent function? A. So that way you know that each time you are comparing graph A with the new transformation. So if you want to shift it down 4, start with A in your head and shift it down 4. Or if you want to flip it over the y-axis, start with A in your head and think about what it would look like if I flipped it this way over the y-axis. You have A as a reference. All the other ones have been transformed. See if you can match the letter to the equation. I think you can. Do the best you can, kind of multiple choice, see if you can match them up. And then we'll do a couple other from the next page. Looks like the turtle survived. Show them the answers for people who are going to watch this video. Here was the answers to 408. Hope you tried it on your own. All right, so here you go. 5 to the x. So 5 to the x, we need to do our parent function. And I said use these 3 points, right, at -1. So how does this change? So at -1, it's going to be 1/5, right, because it takes the reciprocal. At 0, it's still 1, and at 1, it would be at 5. So you're going to use a new parent function. So 0, 1 always. 1, 5. 1, 2, 3, 4, 5. It's steeper. And then 1/5. So there's my parent function, and y equals 0 is the asymptote. And it says state the domain and the range. So the parent function, what would its domain and range be? All real numbers for domain, right? It goes forever, left to right, but it starts here and then it only goes up. So y has to be strictly greater than 0. All right, so 1 and 2, those just are single transformations on this graph. So this will be good practice to see if you can do them on your own in a minute or with a partner. Let's look at 1 and 2 together. Just make sure you got it. What is the transformation happening for number 1? What's it doing? Left 4. So I'm going to write left 4 on the line. I'm going to answer these 3 questions after I've graphed it. To me, it's easier to plot the original parent function first because I know it's 0, 1, 2, 3, 4, 5, 1, 5, and this would be -1, 1/5. Then I can just take those 3 points and count left 4 without having to do it in my head. So I would just dot in on every single graph those 3 points. Why did I skip 2? Because 2 is 5 squared, which is 25. It's not 10, right? 5 squared is 25. So it's shooting up so fast, it's off my graph. Don't graph 2, 10. That's a common mistake. So left 4. 1, 2, 3, 4, I plotted. 1, 2, 3, 4, and 1, 2, 3, 4. Here we go. So there's that. Let's answer what the asymptote, domain, and range are. So the asymptote hasn't moved, right? Still y equals 0. And I could plot that if I wanted to down here. My domain and range also have not changed. They only change if you shift up or down. So domain is still all real numbers, and y is greater than 0. Do you think you can do 2, or do you want to do 2 together before we do the back page? Think you can do it? I think you can do it. Plot the parent function and the transformations. You're going to try to do 2 through 6. And then when you get through number 6, you can move on to that exponent circuit 411, and I'll try to walk around and help you. So in about 10 minutes, I'll put up the answers to the graphing. So you can check your answers to the graphing. I'm sure you didn't make a mistake in pen like I did. This was down to y equals -2. So that keeps the same domain, but the range is y is greater than -2. Should have been what you got. And then go on to the back page. I need you to banana. Would that be helpful? I'm going to write them up just in case people wanted to check their answers to the graphs. So this one, 1, 2, 3, 4, 5, is a flip upside down. 1, 2, 3, 4, 5. So it would have looked like this. So your asymptote would still be at 0. Y is less than 0. flip over the x-axis. Can you see that? Okay. This one would be over the y-axis. 1, 2, 3, 4, 5. So it's here, here, and here. But still y equals 0, all real numbers, y is greater than 0. So I'll leave question 3 and 4 up just for like 1 more minute, so you could check them if you wanted to. Okay, I'm going to put up the last 2 for the graphing. So this should go left 1, down 3. 5. Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. Kind of hard to see, but let's see. My asymptote should have been at -3, all real numbers, y is greater than -3. This would be up 2. 1, 2, 3, 4, 5. So y equals 2, all real numbers, y is greater than 2. So that way your graph should be completed. Who else can I help on the exponent circuit? You guys didn't, you finished yours. Jake, did you finish half? You have 1 more to do. Check that out, huh? All right. How did you go, Nancy? Okay. How did you do? So well, good. All right, James,